Okay, so now we're going to take a look at some applications of arc length and what we can do with that. So in the following two examples, we are given that the Earth's radius is approximately 6,400 kilometers. What we're going to do is we're going to find the distance in the first example between city A and city B. So city A is right here and city B is right here at 27 degrees north and 51 degrees north respectively. So what we're going to do is compute first the angle between the two cities. And in this case, all you'd have to do is subtract. Okay? So 51 minus 27 is 24 degrees. Okay? So that is the measure of the angle. We know the radius of the Earth to be 6,400 kilometers. And we know our arc length formula is S equals R theta. The radius being 6,400 kilometers, the angle theta being 24 degrees. But remember, for arc length, it is necessary for the angle theta to be in radians. So we're going to multiply then by our conversion factor. 24 times pi over 180. Okay, so this is quite simple. All right, this is something that you could just do on your calculator. If you compute all of this, 6,400 times 24 pi divided by 180, because this is your r theta, and that is what S equals. So we're going to end up here with a total of about 2,681 kilometers. That's how far apart these two cities are. Okay, so now in the next example, it's slightly different, and let's see what we've got. All right, so let me box this one real quick. There's our answer. Now in the second example, it says find the latitude of Winnipeg, Canada, if Winnipeg and Austin, Texas are 2,234 kilometers apart. So I've drawn my grid here. Now let's think about it. Which dot would represent Austin, which would represent Winnipeg? Well, I suppose Austin is somewhere down here and Winnipeg somewhere up here near the north, right? Winnipeg has to be north of Austin. And right here, we're saying then the arc length is given. We want to find the angle theta. All right, so we know S equals R theta, and the radius again is held constant, 6,400 kilometers. And we know S is 2,234 kilometers. R is the radius of the Earth at 6,400 kilometers. And so we need to find theta. All right, so what we're going to do is we're going to say, okay, 2,234 must equal then 6,400 times theta. So what we will do is we're going to divide both sides by 6,400, okay, and this will isolate our theta. Now in this case though, whatever we get here is in terms of radians. So let's think about the manipulation of the formula. If S equals R theta, then theta equals S divided by R. And that's exactly what we did here. So in this case, we're dealing with about 0.35 radians. Well, that's great, but we need to know the angle between these two. So what we're going to have to do next is multiply by the conversion factor. So this here is 0.35 radians, and I'm going to multiply it by 180 degrees divided by pi radians, and that's going to get rid of my radians and give me a degree mark. And so I end up with a theta of 20 degrees. So theta is 20 degrees. But this still doesn't answer the question, because the question was, what is the latitude of Winnipeg? Well, this is actually not too terribly difficult now, because what do I know? Here is Austin, and we're going to put it on here. Austin happens to be, and it looks like I never wrote it down. Sorry about that. But I'll tell you this. Austin, Texas is at 30 degrees north. So that's important, 30 degrees north. But thankfully it didn't come into play until right now. So Austin is at 30 degrees north. The angle between is 20. So 30 then plus 20 puts Winnipeg at about 50 degrees north. So what did we do? We took the 30-degree mark of latitude and we added the 20 degrees that we calculated as the angle between, and that's how we got 50 degrees north. So the latitude of Winnipeg being 50 degrees north, and the answer to our question here. Okay, so hopefully these two examples on arc length were relatively easy for you, and hopefully you understood some of these applications of arc length. And remember the formula, S equals R theta.